Hello and welcome back to Calculus 1. We are going to finish our section 3.9 with logarithmic differentiation, and I have a question for you. How about we just forget everything we learned in chapter 3 and just take a look at the problem, take the derivative mentally, and just move along? No steps, no rules, nothing. You just look at the problem, you write the solution in factored form, and you walk away. No product rules, no chain rules, nothing. Yeah, that's this. So when I figured out the power of this thing as a student, I asked myself, why did we just waste a month learning chapter 3 if I could have just done this, right? It doesn't really cover 100% of situations, but holy nightmare, this thing is powerful. So as usual, I like to show it off first to motivate you to actually study this and learn it. And then we take a look at the mathematics behind it, but then also we learn what the mental shortcut is. If you practice this, you would be taking derivatives mentally as someone is writing it on the board or whatever. And if you don't practice it, then you will just work out the steps from calculation and be done with another method that is added to the pile of chapter 3. So let's take a look at whatever. Give me something for the parenthesis over here. What should we put? Like 4 10x to the fifth minus
10. Yeah.
Oh, tangent.
Tangent.
Sure. Tangent x to the fifth. Or you want tangent to the fifth x. It's not the same thing.
Doesn't matter.
Times cube root of x squared minus 14 it is, divided by, so we put in some quotient rule as well. What should I put here?
Sine squared x.
Sine squared x it is. Nah, fine. You can literally put whatever you want. Doesn't matter. So what is the derivative of this using standard methods? Well, you take a look. Oh, this is amazing. I have a quotient rule in general, and then when I am ready to do the derivative of the top, I'll have the product rule, and all three have the chain rule, which means that you have to turn your notebook sideways, then glue the paper next to it, and then do the problem across. Right, that's pretty much how this would work. And then by Thursday next month, you will have the simplified version for the answer. Right, that's pretty much what this problem looks like. Now I'm gonna sound like Morpheus from Matrix. What if I told you that you can take the derivative of this mentally, meaning you just write the answer in factored form and walk away, no calculations, no nothing. So this is what it is. You copy the problem as is. This is the answer. You copy the problem as is. Don't change anything. So it's tangent to the 5x times the cube root of x squared minus 14 divided by sine squared x. Times, and this is the part where you have to put mental power in it. We are looking at 5 tangent x secant squared x plus 1/3 of x squared minus 14 with a 2x minus 2 times, or actually plus 2 times cotangent x. There you go, done. This is your derivative in factored form. And you walk away. So you can learn this in logarithmic differentiation. But it only works if you are masters of these three formulas which I asked you to review last time we talked. I asked you to review and practice the skill of breaking down complex expressions through these log formulas. Please observe that each of the three groups over here, factors, received its own ln, that all exponents on the argument went in front as 3.5 and nothing over here. The power of this method lies in your ability to mentally decompose these. If you are able to mentally decompose these things, the rest is a joke. Because derivative of ln, you write the function as is on the bottom and its derivative on top. So this would just be 3, 1 over x, 1/2, 1 over x plus 1, and minus sine, cosine, negative cosine, plus cotangent. So if you are masters of these formulas, and if you are able to do the pre-calculus decomposition of these logs, the rest of this is a joke. This rule here kills all of your product rules. This rule kills all of the quotient rules, and this one kills all of the chain rules. And you're just dealing with these, and we already have one student on board who's loving it, right? Because
Yeah, no, this is fantastic. I can solve my homework faster and not care about stuff anymore.
so now, having those problems that I messed up before, right? Those problems become a joke, right? Because they all looked something like this with the quotients and chains, right? It would literally take about 30 seconds to solve each one of them correctly, and we will. We'll go back and solve them all in 30 seconds, and you can put the timer on. I should be actually beating 30 seconds on each one of them, but that's okay, right? So how do we learn this and how do we practice this? Well, and why does this work? I want to explain this using much shorter versions of these problems. So let's just have a function given as, say, x cubed times 4th root of x divided by, let's say, sine x. So this is, you know, not having too busy. It's just, you know, all the functions are short and sweet. How does this work? Well, we put ln on both sides. That's where we start. The left-hand side will remain ln y, and the right-hand side in the expansion would be 3 ln x. Remember that all of the exponents jump in front of ln, right? So 3 ln x, and then plus 1/4 ln x, and then finally on the bottom minus ln of sine x. So all I did is I used the three formulas to expand something, and guys, you learned this in your pre-calculus course, probably invented by now. Please review it. Now I hit this with the derivative. Observe that I have ln y on the left-hand side, so I have to deal with that as well. The derivative of ln y is 1 over y, and then I took the derivative of y in respect to x. That's the chain part right there. On the right-hand side, derivative of ln x is 1 over x. That's cheap. 3 times 1 over x plus 1/4 times 1 over x minus, if you are remembering what the derivative of ln is, you copy the function in denominator and you put its derivative on top. So derivative of sine is cosine. Oh, did I? Yeah, I made a mistake. This was supposed to be a minus over here. It's okay. Alright, so now, you see this 1 over y? That needs to go to the other side, and this is why you're copying the function every time. So to get dy dx on its own, you have y times 3 over x plus 1 over 4x minus cotangent x. All you need to do is to swap y with what y was, which is x cubed, 4th root, right? So dy dx is equal to x cubed 4th root of x divided by sine x times 3 over x plus 1 over 4x minus cotangent x. So this is why it works. You will have ln y on the left-hand side all the time, and that will always become 1 over y, and you will always have to move that 1 over y to the right. So, when you are doing this problem mentally, you always start by copying the problem as is, because that's this y that propagates through the problem. This parenthesis here is from breaking down the problem, which is what kills the chain rules of product rules and quotient rules. You just plow through the problem. And as I said, you either practice this to the point where you can do this mentally and just write the solution out, or you're learning the procedure. Your next exam will have one of these questions on it, and you definitely don't want to go the product rule and quotient rule way, right? Knowing this is a procedure that we are learning. Now I'm asking you, do you want to learn the level 1 or the level 2? Level 1 is this. You just learn the procedure and you regurgitate the procedure on the exam. Level 2 is you actually spend 5 hours on this and are able to mentally do this on any problem. So let's do more examples to see. I subbed in y, right? Because the problem is stated y equals that. Before you put red ln's, y equals this. This is what you're taking the derivative of, right? So that's y, that's the function. So when you put ln's in and you differentiate, you get 1 over y, you get y. Well, y is equal to that mess. So I just replaced that for y. Let's do another example. Well, how about one of the problems that you had? So, which problem would you like to give me? One of those before. Like, what was the first one that I messed up? The one with 5 quarters or 3 quarters or something like that. Or no, negative 1/3.
Y equals 9x over 5x plus 6 to the 5th power.
Like this?
No, the whole thing in parentheses.
Well, the entire problem, like this. To the 5th power?
Yes.
Okay. So now, this is 9x to the 5th power divided by 5x plus 6 to the 5th power. And I ln both sides. So what do I have? I have ln y is equal to 5 times ln 9x minus 5 times ln of 5x plus 6. So that's that. No, this is the problem I did right.
No, yeah, sorry.
That's fine. We'll do the next one.
Okay.
So now when I take the derivative, what was the next one that I
Yeah, sorry.
missed? So now we're taking the derivative, and we have 1 over y dy dx is equal to, and now we're taking the derivative of the right hand side. Remember, copy the constant, right, the 5 and coefficient, and then the derivative of ln is always write the function as is, put its derivative on top, minus copy 5, put the function as is on the bottom, put its derivative on top. Move y to the other side, which would be 9x over 5x plus 6, everything to the 5th power, times, and over here, 9 and 9 will cancel. I have 5 over x minus 25 over 5x plus 6. Done. You have the factored form. If you have to say equal to 0, you will set each of the parentheses to 0 and solve each of the parentheses to get numbers. It is very quick calculation for chapter 4 out of here. Now let's get the bad one.
Okay. Ready?
I was born ready.
Okay. 3x squared. No, that wasn't it. Sorry.
Well, who's not ready over here?
I'm looking for the one with all the white out. X in parentheses 2x plus 3
That's the one.
to the 1/3.
Okay, so I'm gonna call that a cube root over here, so we make it look like. So this is the problem, and if you remember over here, what I did is we had 1/3, and then I put it in the denominator as if it was negative 1/3. So yeah, so that was the mistake, but that's okay. Implicit differentiation to the rescue. I have a product rule and a chain rule in the problem, and I'm going to eliminate both of those by using log differentiation, so ln and ln, and then immediately now ln y is equal to, I just have ln x, there is nothing, there are no exponents or anything, it's just ln x, plus 1/3 of ln of 2x plus 3. So I used those formulas to break multiplication into addition of arguments, and then all of the exponents on those arguments, in this case is 1 goes in front of ln, and the other one is 1/3 goes in front of ln. So those are these formulas at work, the blue formulas up there. You either know them or you don't. You should know them because that's the pre-calculus. It's called pre-calculus, right? Needed in calculus. Once I break everything apart, we are ready to hit this with the derivative. We get our 1 over y dy dx is equal to 1 over x plus 1/3, copy the function as is, its derivative on top. Dy dx is, and now you get to copy the function as is, that's the y, times 1 over x plus 2 times over 6x plus 9. Implicit differentiation ends here. We don't have to simplify this any further and get the same example. We don't have to, because I have 3 factors to set to 0. I'm done. Set this one to 0, get x equals 0. Set this one to 0, get negative 3/2. and set this one to 0 and maybe get something out of that as well. This is the best answer you can have for chapter 4, because it gives you factors at the end, and then each factor is independently calculated, and just zero product rule sets each one to 0. Ta-da! Of course, we'll do one more. Yes? Oh, the answer is no, because I know what you're going to ask.
All the stuff before this is just because you have to know how the wheel works before you decide the bars.
Exactly.
Okay.
And honoring our ancestors too.
I'm not really reinventing the wheel, I'm sorry.
You just want to use it, okay.
Yeah,
Sounds good. Yeah. What else do you have?
The last one that we did.
The last one we did, I like it. Bring it on.
So y equals
The fourth root.
2x over 9x minus 7 and underneath bracket. Yeah.
We're good? Perfect.
It's not showing.
Boo. See? You just have to scare it. So what I have is 2x to the 1/4 divided by 9x minus 1 to the 1/4. As you split this, and then you have your ln